A poker hand consists of 5 cards from a 52 card deck. Each card has a suit, either heart, spades, clubs, or diamonds, and a value, ranging from 2 through 10, and Jack, Queen, King, and Ace. Our first question, how many different poker hands are there? Because there's 52 cards available and a poker hand consists of 5 of them, the answer is 52, choose 5. This is 52 times 51 times 50 times 49 times 48 divided by 5 times 4 times 3 times 2 times 1. Some cancellations gives us that this is equal to 26 times 17 times 10 times 49 times 12, and altogether equals 2,598,960. This will be a helpful number to keep track of as we work through the probabilities of different poker hands. Some kinds of hands have special names. We could have a single pair, which looks like exactly 2 cards sharing a value, and no other cards share a value. An example would be a hand that consists of a 2 that's a spade, a 2 that's a heart, a 9 that's a heart, a king that's a club, and a 7 that's a spade. Our one pair is the 2 of spades and the 2 of hearts. Or we could have 2 pairs in which we have 2 sets of 2 cards sharing value, where these 2 sets are of different values. And the 5th card is a new value. As an example, we have 2 of spades, 2 of hearts, 9 of hearts, 9 of diamonds, and king of clubs. We have our 2 pairs. We could also have 3 of a kind, an example of which is 3 of hearts, 3 of spades, 3 of diamonds, 6 of clubs, and ace of diamonds. Or we could have a straight, which is where the values sequentially go up by 1, an example of which is 8 of spades, 9 of clubs, 10 of clubs, jack of hearts, and queen of diamonds. We could have a flush, which is when all 5 cards have the same suit. So 2 of hearts, 4 of hearts, 7 of hearts, queen of hearts, and ace of hearts. And the last that we'll give an example of is a full house, which is a pair and a 3 of a kind. So 2 of hearts, 2 of diamonds, 7 of clubs, 7 of spades, and 7 of diamonds. And there are a few more, but those will be enough. So let's try to find the probability of one of these. What's the probability of one pair? Well, we know that's going to be the number of one pairs over number of hands. Now we've already calculated number of hands to be that 2 million number, 2,598,960, which again is 52, choose 5. To try to count the number of one pairs, let's actually break down what our hand would look like. Amongst our 5 cards, we'd have 2 that have the same value, and since they have the same value, their suits do not repeat. The remaining cards have values that are all different, so the values do not repeat, and the value is not the same as our pair, and since the values do not repeat, the suits can repeat. Breaking down our hand like this is going to make the decision algorithm much easier for us to set up. Our step 1 will be to choose the value of our pair. Because there are 13 different values, we'll have 13, choose 1. Our step 2 will be to choose the suits of pairs. Because the suits don't repeat, this is a combination question, so 4, choose 2. Next, we have to choose the values of the remaining cards. And since they don't repeat, it's a combinations question. And since it's not supposed to be the same value as our pair, instead of having 13, we'll only have 12. 12, choose 3. Lastly, we need to choose the suits of our remaining. And I could break this down into another 3 steps, choosing the suit for each one, but I'll say it's 4 times 4 times 4. So 13 choose 1 is 13, 4 choose 2 is 4 times 3 divided by 2, so 6. 12 choose 3 is 12 times 11 times 10 divided by 3 times 2. 12 divided by 6 is 2, so we have 220, and 4 times 4 times 4 is 64. So our number of hands that include one pair is 13 times 6 times 220 times 64. And this number is 1,098,240. So to go back to our original question, the probability of one pair is this 1,098,240 divided by 2,598,960, and this rounded to 4 decimal places is 0.4226. Let's also find the probability of 3 of a kind. We know this is the number of 3 of a kinds, or number of hands that include a 3 of a kind, divided by the number of hands, and that we've calculated the number of hands before to be 2,598,960. To calculate the number of hands that include a 3 of a kind, let's break down what our hand would look like again. Here, the first 3 are going to be all the same value, and the suits won't repeat. Our remaining 2 will be 2 different values. If they were the same value, it would be a full house, and neither are the value of the 3 of a kind. Because they're different values, the suits can repeat. So step 1, what's the value of our 3 of a kind? There are 13 values to choose from, and we're looking for 1, so 13 choose 1. Our step 2 will be the suits of our 3 of a kind. There are 4 to choose from, and we're looking for 3. Step 3 will be the values of the remaining 2 cards. So we'll have C of 12 choose 2, and our final step will be the suits of the remaining 2. And because this can repeat, it's 4 times 4. So we have 13 choose 1 is 13, 4 choose 3 is 4, 12 choose 2 is 66, 4 times 4 is 16. We get that the number of hands that include a 3 of a kind is 13 times 4 times 66 times 16, which equals 54,912. So our probability of 3 of a kind is 54,912 divided by 2,598,960, which, when rounded, is 0.02113.